What's up, people? What's going on? So, ladies and gentlemen, this is me, Yawar Manzoor, and I believe everybody of you is doing great, nice, and absolutely fine, okay? And I just want to know in the live chat itself if you can hear me and if you can see me properly. It would be great. Okay? Yes, we are live. Good evening, good evening. And before everything, I want you people to basically like this video as soon as possible and subscribe to the channel. Hit the bell notification so that I'll get the update. You will get the update every time whenever I come live, whenever we come live on this particular channel, okay? All right, ladies and gentlemen, what's going on? Yes, hi. So, welcome to JEE English Unacademy. This is me, Yawar Manzoor. I am your JEE Physics teacher. And I want you people to subscribe it right now if you haven't, and hit that bell notification so that you'll get the update every time whenever we come live. And I just want to know, yes, mark the attendance. I just want to know in the live chat if you can hear me and if you can see me properly. And is everybody doing great? Okay. So, people, today we will be starting the new chapter, that is circular motion, okay? We'll be basically talking about some of the beautiful and some of the beautiful angular things. Understand, some of the angular terms we're gonna be entering in the angular terms. This will definitely help you in your rotational motion as well. Understand, if you have any sort of confusion, if you feel rotational motion is basically tough, so this is the basic lecture in rotational motion as well, over here as well. Understand, so that's why it's mandatory for all of you to learn these things very properly, these angular terms very properly, so definitely it will help you in your upcoming time as well. Okay, so this is a piece of information about me. Ladies and gentlemen, my name is Yawar Manzoor, and I just need to give you the update. We will be launching a series from 1st onwards. That's for droppers and 2022 people. You will definitely love that series for sure, okay? Yes, I'll send you the dozens of apples from my garden. Don't worry about that. Yes. Okay. And you can definitely follow me on Unacademy. This is my username over there. This is my username on Unacademy. Just hit the follow button as soon as possible because you will get the update every single time whenever I come live over there as well, okay? And apart from this YouTube platform, we teach on Unacademy's own platform. Over there, country's top educators basically teach you, okay? Yes, we will be launching the new series. We'll also run this series. Apart from this, we are launching the new series as well. Don't worry about that. The people who are attached to this Fury Live, you don't have to worry about anything. Classes will be regular for this as well. And the new series as well. You will love that, everybody. No, that will be for YouTube, okay? And on Plus, we are launching the series as well, okay? As well as Plus from 1st onwards, okay? And apart from this, as I told you, country's top educators are teaching you inside Unacademy. So if you people want to learn from those educators, if you people want to take your rank to the next level, I suggest you to basically go for this Plus subscription, okay? And even you can go for this Iconic subscription as well. One of the beautiful subscriptions, golden subscription. I suggest you to go for this, okay? There, you're gonna be basically getting the live classes. You will say, sir, why are we supposed to take this Plus and Iconic subscription? You might have seen the results recently which Unacademy has produced in JEE 2021. AIR 1 was definitely from Unacademy, and more than 100 learners were having 99.5 and above percentile. So if you people want to basically be in that category, take this Plus, take this Iconic, because country's top educators will basically educate you. They will take your rank to the next level as well, okay? And in this Plus, you will be getting the live classes every single day, weekly tests every single day, structured courses. Once you are done with your entire thing, whatever you have studied, you will be having weekly tests and this unlimited access. This unlimited access is, for example, you want to create your own batch inside Unacademy. For that, you will have to basically go for this unlimited access. Understand? If you love this particular educator from this batch and the other one from the another batch, you can pick up all these educators and create your own batch. That's what we call the unlimited access. Even you can watch anybody's lecture any damn time in a particular category. And if you take this Iconic subscription, you'll be getting personal guidance and all the benefits you get in Plus. You'll be getting test analysis, experts guidelines, study material, study planners. Okay, so this is the stuff that you're gonna get in this one as well. And now the point is for how much amount of time you can take this Plus subscription and this Iconic subscription. For sure, definitely you can take this Plus subscription for 3 months, 6 months, 12 months, 18 months and 24 months. Okay, by using this code you can get the maximum possible discount for sure. And most importantly, EMI options are available as well, so you don't have to worry about anything. Okay, so EMI options are available as well. Okay, so EMI options are available as well, so you can pay it every single month. You don't have to pay this entire amount at once. Now the another part is that is you will be, if you take this Iconic subscription, you can take it for 12 months, 18 months and 24 months. Use this code, you can get the maximum possible discount for sure. Okay, by using this code only. Everybody feeling great today? Okay, and these are the batches which Unacademy has launched recently. So I want you people, if you want to boost your rank, enroll in these batches as soon as possible. And use this code to get the maximum possible discount for sure. Okay, Yawar is the code. This is the before price hike. This is the after price hike. Just check it out from the screen itself. Go with this. And we have launched this CBSE Plus JEE combo offer. Understand? If you take it for 12 months, you will be getting it after discount, that is 39,780 rupees only. Okay, and this is the regular price, this is the discounted price, this is the regular price, this is the discounted price. Okay, this much of amount you can save for 12 months, this much of amount you can save for 24 months. Okay, go for this as soon as possible, as soon as this. Next thing is, if you people want to learn free from Unacademy, this is the India's biggest scholarship test. Okay, this is the India's biggest scholarship test. One second, man. If you people want to learn free from Unacademy, so you should go for this scholarship test. Understand? This is the India's biggest scholarship test. Even if you get the rank from 1 to 3, you'll be getting 100% of scholarship. If you get the rank from 4 to 10, you'll be getting 75% of scholarship. Even if you can get up to 4 crore plus scholarship, Yawar, you can use the code while you enroll. So this test is basically on 26th of September, 11 a.m. Understand? Is the 26th today? Oh, it's done. So next it will be, yes, hi Praveen, what's up? What's going on? And we have this beautiful feature on Unacademy, that's Ask a Doubt. If you have any sort of doubt, you can ask. You can even ask the unlimited number of doubts. You can ask the doubts on Unacademy. You can ask the unlimited number of doubts. You can ask the doubt any damn time. You will get the high quality video solutions, that too in very less amount of time. And how you can exactly ask this doubt, there is a doubts and solutions option over there. You need to basically select the picture, upload it on Unacademy. Make sure the picture should not be blurred. It should be very clear. Understand? And the picture, you need to basically crop that particular doubt. It's not like you'll send 10 or 15 doubts in just 1 second. In just one picture, that's not allowed. That's not permissible. Okay? So ask a doubt. These are the do's and don'ts that you need to keep in your mind while you basically ask this doubt. So ladies and gentlemen, let's basically talk about this circular motion, what this all about is. Understand? You'll say, sir, this is nothing but 2D motion, two-dimensional motion. Okay? What is two-dimensional motion and what is one-dimensional motion? Circular motion, in simple words, we say basically, see, I'll just give you a brief introduction. What we're gonna be basically talking in this circular motion. In this circular motion, today we will be talking about the angular terms. Like in your kinematics, in your previously linear motion, motion in straight line over there, or motion in one dimension. Over there, you have studied, sir, velocity, that is nothing but linear velocity, linear displacement, linear acceleration. So these are the terms that you have studied previously. Today we will be talking about if the body is moving in a circle. So we say the body is moving angularly. I'll explain you this also. So we say over here, there will be angular velocity, there will be angular displacement, there will be angular acceleration, tangential acceleration, centripetal acceleration, okay, net acceleration, radial acceleration, everything we will be talking about in the today's session only. So this is the brief introduction. This is basically what we have to deal with in the today's lecture. Understand? Before that, what is the circular motion? We say in simple words, if a particle, if anybody is, for example, moving in a circle, this is nothing but circular motion. What is a motion in one dimension, motion in a straight line? Sir, this is motion in a straight line. This is going on a straight road. Understand? It's not changing its direction. Understand, this is moving in uniform direction. So we say this is a motion in a straight line. This is a motion in a straight line. It's falling down. Now in this circular motion, when a particle is basically moving in circle, we say this is nothing but circular motion, in simple words. Now, from physics point of view, we say it is nothing but two-dimensional motion. Understand? If we talk about this motion in one dimension, motion in a straight line, one-dimensional motion, this is nothing but something like this. Understand? This car is traveling on a straight road. Understand? You'll say, sir, this is one-dimensional motion. One-dimensional motion is that motion in which only one of its coordinates are changing. Understand? If I say, for example, at this point, its value of x is, you'll say, sir, value of x is 1. Understand? 1. Over here, sir, value of x is 2. Understand? So it's changing in x. What is the value of y? You'll say, sir, y is equal to 0 or y is equal to 1. So that remains constant because it's not going up. If the particle is going like something like this, so in that case, we say basically the particle is moving in two-dimensional motion. So this is one-dimensional motion. So over here, if we say the particle is going something like this, it is traveling in x as well as in y. The particle, when it is over here, so it has covered this much of x. For example, this much is the y and this much is the x, if we say this is the origin. So in this case, we say basically this is nothing but the example of two-dimensional motion in which two of the dimensions of the body are changing. So that's what we call the two-dimensional motion exactly. Okay? Now, let's basically try to understand this from one more example. So let's basically have a look on this example, the definition that is written on the board over here. Try to have a look on this one. Saying that for example, if I have a particle, understand, if I have a particle over here that is traveling something like this, this is a particle, understand, this is a body, understand, it's traveling something like this, fine. Now, when a particle moves in a plane, so I'm saying that this particle is moving in a plane over here. What is this plane? We say this is a plane. Understand? For example, this is a plane of a board. We say this is a plane over here. Understand? This is a plane. This is x coordinate, y coordinate. It makes a plane. Understand? That's what we say. This is a plane over here. So we say if a particle moves in a plane such that its distance is fixed, such that its distance from a fixed point is constant. Understand? Now see, if this particle is basically moving in this plane, something like this is a plane over here, okay? It is moving in a circle. I would say it's moving in a circle. Understand? So if this is moving in a circle, with respect to this point, the distance between this particle and this is always constant. You'll say, sir, how? Listen to me, how? When the particle basically reached this point, can I say the distance is exactly this? 100%. When the particle is basically reached this point, because this is moving in this path, this curved path or this circular path. So can I say the distance between the particle and this point? That's we call this point as C. From this point to this point it is C exactly. From this point to this it is C when the particle is at this position. Over here it is something like this. So it is saying that when the particle moves in such a plane, such that its distance from a fixed point remains constant. This distance remains constant. Such that from a fixed point, this is a fixed point, it remains constant. So we say this distance is nothing but radius. Understand? This distance is nothing but radius. It remains constant because radius is constant. If you move in this circle, okay? So we say then its motion is called the circular motion. So we say then in that case, this particle is basically moving in a circle. A very simple definition. First of all is it's a two-dimensional motion because two of its coordinates are changing, x, y over here. This is moving in xy plane, okay? Next point over here is, we say, sir, it is that type of motion. It is that type of motion in which the distance between this particle and a fixed point, one fixed point, that remains constant throughout the motion. So that is this. This is what we call the center. And this distance, which is the constant distance in that case, that's what we call what? This is what we call the radius. How many of you people understood this one? Come on. Come on, I just need to know in the live chat. Give me some thumbs ups, give me some hearts, whatever you want to send. I just need to know if you understood this. Come on, man. Now, okay, that's great if you understood this properly. Next example, okay? We'll just basically do the analysis of this angular motion. People say this angular motion, what this angular motion is all about. Let's talk about this angular motion only. Understand? See, how exactly I'm going to make you understand this angular motion. If I say, for example, this is a person A, understand this is the person A, and this is the person B exactly over here. This is the person A, and this car is basically traveling on this road. This is the person A, this is the person B, this car is traveling on the road. If I ask you over here, tell me one single point, one single common point. With respect to this person, is this car moving linearly or angularly? Is this car moving in a straight line or angular, angular motion? You'll say, sir, with respect to this person A, this car is moving in this direction, in a straight direction, unique direction. So clearly, with respect to this person, if he has to keep his eye on that particular car, this person is clearly saying, sir, this car is moving in a straight line, motion in a straight line, clearly. So I can say over here, with respect to person A, car is in straight line motion. Okay? Any sort of confusion in this one? No. Because he is basically keeping his eye on that particular car like this. Understand? He doesn't have to basically tilt his face. He doesn't have to basically tilt to his face. Yes, exactly. Linearly, 100%. Now, with respect to this person B. Now, if I ask you, with respect to this person B, the person B is exactly something like over here. Okay? The car is basically traveling something like this. This was the person A. Now this is the person B. Understand? So when this person B is observing the car is traveling something like this, something like this, something like this. If this person B has to keep his eye on this particular car, what he has to tilt his face. He has to basically tilt his face. So initially he was looking at this car at 0 degree angle. I call this as 0 degree angle. Then he was changing the angle. This is some angle. Understand? 30 degrees. Then 40 degrees. Okay, then 80 degrees. Understand? Something like this. Something like this is happening. So basically he is changing this weaving angle. Can I say it like that? 100%. So in that case, can I say with respect to this person B, this car is moving angularly, because this is moving angularly. If I have to keep my eye on that particular car, I have to tilt this face. I have to tilt my face. So this car is moving angularly. See, this is the first 0 degrees. Then I keep on increasing the angle. Understand? With respect to this line, increasing. So angle, now this much is the angle. This much is the angle. So can I say in that case, this is moving angularly. This is the first, I call this as theta1. Understand? Sir, this is theta1 and I call this as, for example, theta2 over here. So can I say it like that? Any sort of confusion till here? Understand? You got the feel of what is angular motion. So this is what we call the angular motion over here, in which basically he has to tilt his face. This is moving angularly with respect to this person B. With respect to this person here, this is moving linearly. Come on, in the live chat, give me some signal if you got it. This is very helpful. When we basically start the rotation motion, the first lecture will be this only. Entire first lecture will be this only. That's why I keep saying you this again and again, and you need to basically focus on this more properly. Now listen to me very carefully. Listen to me very carefully. If I say, for example, could you please tell me, with respect to this person A, what is the angle? With respect to person A, the angle was basically theta is equal to 0 degree. I was basically keeping my eye on that person, on the car. So it is theta is equal to 0 degree, 100%. So can I say throughout the motion that theta remains constant? Understand? This car is going in this direction. Okay, or this car is going in this direction. So theta remains constant, 0 degree, 0 degree, 0 degree. So in that case, we say basically theta is constant. Understand? 0 degrees means constant. Understand? Theta is not changing in that case. So if theta is not changing, can I say in that case this? Can I say in that case this d theta by dt is nothing but 0, 100%. Rate of change of with what rate this is changing? That is nothing but 0, because theta is constant. Theta is not changing. This is what? Rate of change of what? Theta with respect to time. I'll tell you after some time what this exactly is. So we say this is in case of linear motion. Understand? And in case of with respect, this is with respect the person A, with respect to the person A. Can I say with respect to the person B, with respect to person B, car is moving angularly. Okay, I can definitely write like that. So can I just say in that case d, not this d phi flux, this is d theta. In that case, this d theta by dt will not be equal to 0. It will have some value because theta is changing exactly. Okay, because theta is changing exactly. Yes. Don't worry about that. Okay, so we say basically theta is changing exactly in that case, d theta by dt. See, if you want to take my practice sessions, then come to my special classes. Over there, we basically regularly solve the previous year questions of all these chapters every single day. Now see, so we say in that case over here, so this is not equal to 0. This is clear. Is this clear? Then I'll move forward. Then I'll have to go to the kinematics of this. Is this clear? Okay, that's great. Now, let's basically talk about this one. Kinematics of circular motion, okay? Previously, we have studied in our previous lectures that velocity. For example, if I say this car is traveling from this point to this point, you'll say, sir, how much displacement it has covered? You'll say, sir, S, displacement. This is what we call the linear displacement, okay? Linear displacement. How much linearly it has displaced from its original point. Understand? So this is what we call the linear displacement. We studied linear acceleration. We studied linear velocity. Understand? Thanks, man. So we studied linear acceleration, linear velocity, linear displacement over there. Now let's talk about this angular displacement. So can I say right now, if the body is moving in a circle, it is moving angularly? You'll say, sir, how? We didn't get the feel of this one. Previous example was different than this one. I'll give you. Don't worry about that. Okay. So I can definitely say that over here, when the body is moving in a circle, it is moving angularly. Listen to me very carefully. This frame of reference is very important. If I say, for example, there is a particle, okay, this is a particle exactly, or this is a body, this is moving in a circle, something like this. Now you came and you're sitting over here, okay? You are sitting exactly over here. This is you. I call this as Y. Okay, this is me, Yawar. So I'm observing this particle from this frame, from the center exactly. Now, if I keep looking at this particle, can I say that this is moving angularly because it is cutting some angle? When it reached from this P to basically this Q, so this has cutted some basically angle over here. Understand? So basically this has moved some angle over here. Can I say in that case this is from P to Q, this angle exactly? 100% I can say it like that. How many of you people agree with me? Okay, so when you are basically observing this particle from the center frame, in that case we say the particle is moving angularly. Now you believe this is the case of angular motion. Now you got the feel of this one. Come on, I just need to know in the live chat. Come on, everybody, give me some signal, man. Okay, so we say basically this is nothing but angular motion. Yes. So we say if we basically observe this particle from the center, so in that case we say this is nothing but angular motion, 100%. Now, first of all, we'll learn basically this angular displacement, what this angular displacement is all about over here. Let's basically try to focus on this one. Understand? Variables of motion or the circular motion. Angular displacement, first of all. Listen to me very carefully. Yes, you got the feel. Listen to me very carefully. If I say, for example, If I say, for example, this particle is traveling from this point to this point exactly. This particle is traveling from this point to this point. In a circle, this particle is moving. Understand? So, for example, it traveled from point P to point Q. This is a circular motion, okay? This particle traveled from point P to point Q. And you are observing from the center frame. Understand? With respect to the center O, you are exactly sitting over here. So, can I say that it has basically moved some angle, this much of angle exactly? I call this theta 100%. So, this is what we call how much the particle has moved angularly. How much the particle has moved angularly. In case of linear motion, motion in a straight line, we say how much the particle has moved linearly from this point to this point. So we say this is nothing but S. This was the linear displacement. Over here, how much the particle has moved angularly. How much is this angular displacement? That's what we call the angular displacement. Understand? How many of you got the feel exactly? Can I just write over here? It is how much the particle has moved angularly. Okay, definitely I can say it like that only. How much the particle has basically moved angularly. You getting this one? Yes, yes, definitely. So over here, so we represent this angular displacement with what? We say basically this is theta. Now you will ask, sir, what is angular position? Where exactly this is with respect to the reference line, exactly over here. What was the position over here? Same is the case over here. So this is what we call the angular displacement. This is what we call the angular displacement. How much has been the angular displacement in this case? Everybody, come on. How much the particle exactly has moved angularly, okay? Okay, so basically we represent this with what? That is nothing but theta. Fine. And we measure this angular displacement, we measure with simply in what we call the measured in, we say radians, okay? Fine. Or you say degrees also. Okay? 360 degree. If you rotate from this point to this point, sir, 90 degree only. Sir, 360 degree. Sir, 270. Sir, 180. If you travel from this point to this point, what is the angle? Sir, 90 degree. Understand? And if you travel from this point to this point, sir, 180 degree we rotated. Sir, from this point to this point and we reached back to the point C, sir, 360 we rotated. Understand? That 360 camera. Or we say that's nothing but, sir, measured in radians or degrees. Fine. Or we say, sir, from this point to this point, exactly 2 pi radians. Understand? So this is what we call the pi by 2. 90 is in terms of radians, pi by 2. So we say from this point to this point, it is 2 pi. Exactly. When you rotate by 360. So you might have studied this in your previous classes. That is this 360 degrees is nothing but, we call this as nothing but 2 pi radians. Rads. Okay. So we say this 180 is nothing but that's pi rads. Can we just say it like that? And we say this 90 degree is nothing but that is pi by 2 rads. Okay. This is the very simple conversion you might have studied in your early classes like 9th class, 8th class. Okay. So afterwards what comes? That is, sir, 45 degree. Can we say that is nothing but pi by 4 rads? Exactly. Fine, everybody. All of you. And what about 60 degree? Pi by 3 rads. What about 30 degree? Pi by 6 rads. So this is exactly the scene, okay? And we say this is nothing but vector. It's a vector. It's a vector. It's a vector quantity. This angular displacement is vector. How you are supposed to find the direction? We say it's nothing but axial vector. Axial vector, which is along the axis. Understand? See, you don't say basically angular, the direction of this theta is, of this angular displacement is something like this. No, you curl your fingers, it will be along axis. Understand? It is something like this. So it will be, understand, this will be what the direction of theta by right hand thumb rule. Understand? This is how you can exactly find the direction of this vector. This is how you can exactly find the direction of this vector. Understand? Like this or like this, depends upon the motion. Okay, this is what we call the angular displacement exactly. Angular displacement exactly. Fine. Everybody clear with this one? Okay, that's great if this is crystal clear to all of you. Let's move on to the next one. direction. Let's move on to the next one. So we say over here, linear displacement. Now listen to me very carefully. Now see, we say over here, listen to me very carefully, everybody of you. Yes. Now listen to me very carefully. If I say, for example, this is a particle, this is a center over here, this is the particle exactly, understand? So this particle started traveling in this direction. For example, this particle started traveling from this point P and this reached the point Q exactly, from point P to point Q. Now, if I ask you very simple question over here, very basic question. You observed this particle from this frame, you observed this particle from the center. Now I'm asking you, you sit on this particle itself, you observe this particle from this frame only, you sit on the particle itself. So when you sit on the particle and the particle travels like this only from this PQ to P to Q, in that case, does it seem like it is moving linearly? You might have studied, for example, this is a car, okay, this is a car, you are sitting on this car, okay, this is a car, you are sitting on this car. So what happens over here, this car is traveling from this point to this point. When you are sitting itself on the car, in that case, can you say I am moving in a circle? No, you are moving, understand, you are covering the linear displacement. This is a curvilinear displacement previously, curvilinear motion. So in that case, but you are moving linearly. Can I say it like that? Not in a straight line, but you are not, with respect to this point, it is moving angularly. But when you are sitting inside the car, it feels for you, you are moving linearly. Understand? Understand? You getting me what I'm trying to say? For you, it feels like, you will imagine like you are moving linearly. You don't know you are moving in some curve or in some circle or something like that. You getting me what I'm trying to say? When you basically observe this from that frame, when you basically sit on the particle, when you are sitting, how do you know that you are moving in some circle? So for you, at that point of time, you're moving linearly. So for example, I say this has covered this linear displacement of S. So this has covered the linear displacement of S. You getting the feel? Come on, I need to know in the live chat. So I say in that case, when a particle, so can I just write when a particle is performing circular motion, it will cover both linear as well as angular displacement. Can I just say it like that? Understand? When you observe the same thing from this frame, so it is moving angularly. When you observe the same particle from this frame, you're sitting on the particle itself, so it feels like it is moving angularly in that case. So can I just say it like that? 100%. Okay. That's great. Fine. So I can definitely say it like that. So we represent this linear displacement with basically what? This is S. You might have studied previously this linear displacement, that linear displacement only. Now let's move on to the next thing. That's nothing but relation between linear displacement and angular displacement. Now see, if a particle is performing circular motion, in that case we say it is covering linear displacement as well as angular displacement both at the same time. Understand? When this particle is traveling from this point to this point, it has moved the angle of this much and linear displacement of this much. So can I say in that case there will be the relation between the linear displacement and angular displacement? You'll say, sir, yes. So I'll just try to make it over here. So for example, this particle is exactly moving from this point to this point, okay? This is the radius R, from this point to this point. So when the particle started moving from this point to this point, so can I say it has moved the angle of theta, I would say, and it has moved the linear displacement of how much? I would say, for example, this S. Understand? From this point to this point. This linear displacement S covered, and this, what is the relation between these two that we are supposed to find out exactly. Now, if I ask you, if the particle has covered this much of distance over here, or the particle has basically moved the angle of 360 degrees, we represent that in degrees as well, okay? Or we say, if the particle has moved by 2 pi radians, okay? For entire one complete cycle, can I say that the particle has moved 2 pi radians, 100%. Okay, 2 pi rads, we say this is 360, or in terms of radians, we say 2 pi rads, 100%. Now, in this 2 pi radians, understand the particle has moved angularly. How much theta? Sir, you will say, sir, theta it has covered by 2 pi radians. If the particle has covered the entire circle, so we say it has covered the 2 pi radians. Can you tell me in this question, in this case, very simple question, that is nothing but how much linear displacement it has covered? You'll say, sir, it has covered the linear displacement from this point, exactly something like this much of linear displacement. And in case of circle, how much is this linear displacement? You'll say, sir, this is circumference. And how much is this circumference? You'll say, sir, this is nothing but 2 pi r. We have studied this in our 6th class. So can I say that when the particle is moving this much of theta, when the particle is moving basically this much of theta, it has covered how much of linear displacement? That is the circumference of this one. That is nothing but 2 pi r simply. Can I just write it like that? 100%. Now, if I ask you, for 1 radian, how much will be exactly this much? How much will be exactly in that case? Say, sir, for 1 radian, I can simply write how much linear displacement it has covered. This is for 2 pi radians, it has covered how much of linear displacement? That is 2 pi r, circumference, okay? For 1 radian, how much displacement it will cover? You will say, sir, for how much linear displacement it will cover? You will say, sir, that is 2 pi r upon this 2 pi exactly. So it will come out to be nothing but r. Means for 1 radian, it will cover only r linear displacement. Can you tell me over here for theta radians, for theta rads, how much will be the linear displacement? You will say, sir, that will be nothing but 2 pi r, this 2 pi r upon 2 pi multiplied by what? That is nothing but theta. So this will cancel. This will come out to be r theta. So what is this r theta? So for theta radians, it has covered this much of linear displacement. So can I say this is nothing but linear displacement S? 100% linear displacement S. So what is the relation coming out to be? You are saying, sir, S is equal to r. Theta is the relation that coming out to be. So this is the relation between linear displacement and angular displacement in case of circular motion. How many of you got the feel of this one? Okay. Come on, man. Okay. If not this one, if you don't like this method, the simple method that you can use, alternative, that is nothing but angle is equal to arc upon radius. Okay, this is with the field, this is without the field. Okay, so you say basically angle is arc upon radius. So how much is the angle over here? You will say when the particle moved from this point to this point, that is theta. Arc is S, radius is this one. You'll say, sir, theta is equal to how much is the arc? You'll say, sir, arc is nothing but that is S, and radius is that is R. So S is equal to R theta exactly. Okay, you got it, man. It's great. That's great. Okay. Now we have this angular velocity. So angular displacement relation is basically done. We need to basically now talk about the angular velocity all about. What is this angular velocity all about? Now listen to me very carefully how I'm gonna basically make you understand this angular velocity. Okay. Now, if I say for example over here, this particle is moving in a circle. Understand? If this particle is moving in a circle, first of all, you tell me what is the linear velocity. You'll say, sir, linear velocity is nothing but, we say velocity is nothing but that is change in displacement delta S upon delta T. Can I just say it like that? Okay. First, we'll discuss the linear velocity only. Listen to me very carefully. Listen to me very carefully. We say this linear displacement is nothing but that is ds by dt or delta S by delta T. This is nothing but instantaneous. This is nothing but average. Means with what rate displacement is changing with time, that is nothing but, if I say for example the particle is traveling from this point to this point, it has covered the displacement S in time t. I'm asking you with what rate the displacement was changing. More fastly the displacement is changing, more is the velocity. Less fastly the displacement is changing with time, less is the velocity. Understand that it's moving slowly. So that is the concept of velocity, how faster it is moving. Understand? Linearly. Now let's talk about the angular velocity. if the particle is basically moving in a circle, so in that case, this is basically moving some angle, it is cutting some angle. So I say theta. If this particle moved from this point to this point, understand? Let me just show you over here. If the particle moved from this point to this point exactly, from this point to this point exactly, this is the particle moved. For example, it has moved the angle of theta. So if this is the linear displacement, when the particle is in circular motion, it is changing its angular displacement. Can I say it like that? It's changing its angular displacement. See over here, it is theta 1, theta 2, theta 3, something. So when there is change in angular displacement, we say there is velocity, there is angular velocity. Like in linear motion, change in displacement is what? Velocity. When you change the displacement means you are traveling, you have some velocity. So over here, when you are cutting this angle means you are changing this angular displacement. So in that case, we say that is nothing but angular velocity. Rate of change of angular displacement. Can I just say it like that? In simple words, rate of change of angular displacement. With what rate angular displacement is changing? More fastly this is cutting the angle, more is the angular velocity. Less fastly this is cutting the angle, less is the angular velocity. So can I say in that case, this angular velocity, we represent it with omega. Understand? We represent it with omega. So in that case, what will be the value of this omega? You will say, sir, for average it will be nothing but that is delta theta upon this delta t. Exactly, we can write it like that. So just put it in the box. Okay, in general, what is this delta theta? From this point to this point, in general, with what rate theta was changing with time? More fastly it was changing, like delta s by delta t. In general, from one point to another point, with what rate displacement is changing? That's nothing but average. This is average angular velocity. In general, with what rate theta is changing with time? Can you tell me what is the value of this? You would say, sir, instantaneous will be simply, that is nothing but this d theta by dt. At any particular point, if I ask you at this point, at t is equal to 15 seconds, how much is the angular velocity? So at that point of time, with what rate angular displacement was changing, that will give us the angular velocity at that point of time. Very basic concepts, okay? Just compare these concepts with the linear motion, you will get the feel. Come on, in the live chat, do let me know if you getting everything. अगर सब कुछ समझ आ रहा है, okay? Yes. So we say we measure it in, that is rad per sec, like velocity in meter per second. Theta in radians, and per time it is second rad per sec, SI unit, okay? Next thing is, it's also an axial vector. Also an axial vector, okay? Its direction is along axis, understand, along its axis. If I say, for example, this is the particle that's moving in this circle, so this will be the direction of this, it's omega, like linear angular displacement, okay? Fine. Same is the case in linear this. When the particle over here, can we say, if the particle is moving in a circle, in that case, the particle is also covering the linear displacement, this linear displacement, understand? So if the particle is moving in a circle, it is covering the linear displacement from this point to this point exactly, it is covering the linear displacement, okay? So it is changing the linear displacement, rate of change of linear displacement with time. That is nothing but velocity, linear velocity, and this will be average linear velocity in that case. Fine. Basic concepts. Simple as that. Some common techniques that I need to basically show you right now. Fine. This is the basics of rotational motion, okay? Once you are done with all of these angular things, people say, sir, I have the pair of these angular things. Understand? Whenever I see angular thing, it keeps messing with my mind. So that's the reason, because you don't know the basics. This is the first lecture. Whenever I start the rotational motion, I start with this lecture only. Because when you understand the basics of rotational motion, analogies of rotational motion is what? rotation motion is all about circular motion only. I say rotation, there is no rotational motion. There is circular motion only. If this rod is rotating, for example, okay, about this point, this rod is rotating. What does that mean? You take infinite number of points over on this rod. So if I talk about particularly this point is basically doing the circular motion about this point. So in rotational motion, all the points, individual points are doing the circular motion. So we call that combination of circular motion as rotational motion. But in general, there is no rotational motion. This is what? This particle is doing rotational motion like this, radius this much. This particle is also doing the circular motion. This particle is also doing the circular motion this much radius. So that's why only 2 more lectures. Okay, we finish the chapters not more than 3 lectures. Okay, we'll just get done with the 3 more lectures. Then we are done with this complete chapter. And we'll cover everything. So some basic common techniques you might have studied in your linear motion. That is nothing but, you say, sir, if displacement is given, we are supposed to find the velocity. What will you do? If displacement is given, you are supposed to find the velocity. What you do? Sir, we go for this one. Velocity is nothing but that is ds by dt. Understand? This is a very simple thing. Now, if velocity is given, you are supposed to find the displacement. Velocity is given, you are supposed to find the displacement. What you will do? Sir, we'll go for the integration. Take it over there. Understand? So we'll write this. ds is nothing but that is v dt previously. If you want the proper feel of this one, then go to the kinematics. So can we just say this will be nothing but integration, this one. So this will cut exactly, or this integration of this, don't cut this one. You will say, sir, later, no, sir. Integration of small ds, it will give you the total displacement. So this is S is equal to that is integration of v dt exactly. This is the scenario that you might have studied previously. Now, same technique we'll apply in the angular motion. Angular motion. What is that? Sir, over here, linear displacement. In angular motion, can we say, if theta is basically given, you are supposed to find omega. How can you exactly do that? Sir, omega is nothing but that is d theta by dt. Understand? Rate of change of this linear angular displacement with time. Now, if angular velocity is given, you are supposed to find theta. In that case, what will you do? Sir, reverse process, take it over there. So that is nothing but d theta is nothing but omega dt. You will integrate. Over here you differentiate, over here you integrate. So integration of this one, integration. So it will give you the total theta. So that is nothing but integration of omega dt exactly. So fine. Yes. Now relation between v and omega, linear velocity and angular velocity. Now see, if I say, for example, the particle is traveling from this point to this point in this case. So you are saying, sir, it is having angular velocity as well as linear velocity, because when you look at this particle when you observe this particle from this frame, you are sitting on this one. In that case, this is moving linearly, so it will have linear velocity. And when you basically observe this particle from this frame, so it is moving angularly, it has cutted some basically angle, it has moved some angle. So we call that theta over here. This is nothing but s over here. So we say in this case, it is having the linear displacement. I call the v, I show that something like this. And it is having the angular velocity also. So for example, I'll show that something like that is along the axis. Okay, keep that thing in your mind. Remember, this velocity is basically what? This is a tangential velocity. This is a tangential velocity. Okay. Praveen is saying v is equal to t omega. No. Now see, how can we exactly find the relation between this and this? You might have studied just 5 minutes back. That is nothing but, if I ask you, so there will be the relation, because when a particle is moving in a circular motion, it has both linear velocity as well as angular velocity. If I ask you in simple terms, what is this omega? You will say, sir, that is nothing but, you will say, that is nothing but this delta theta by delta t. Understand? Can you just tell me, is this correct? 100% from this point to this point, average angular velocity. Now, we know previously, what is the relation between linear displacement and angular displacement? You'll say, sir, S is equal to R theta. Okay, already we know this. Now, can you just put it over here? So you'll say, sir, from this one, I can definitely write this theta will be nothing but that is S by R. Just put it in this one. So omega will be nothing but this delta. Instead of this theta, can I just write this will be S by R 100% upon this delta T. Okay. Now this R is what? That R is the radius and the radius is constant. Take this constant out. You'll say, sir, this is nothing but that is 1 by R. This will be delta S upon delta T exactly. What is delta S upon delta T? Rate of change of linear displacement with time. That is nothing but velocity. So can we just write it will be exactly omega is nothing but, you'll say, sir, 1 by R. Instead of this, I'll just put over here that is nothing but velocity. So can I say in that case this V is equal, take this R over here, that is nothing but R omega 100%. This V is equal to R omega. This is the relation between linear velocity and angular velocity, where this linear velocity is the tangential velocity. Fine. The basic terminologies. Let's move on to the next thing. If theta depends upon the time in a following way, understand? We are given the theta exactly over here, 2t square plus 3, 2t square plus 3. You are supposed to tell me the omega up to 3 seconds. Understand? You just tell me omega up to 3 seconds means you are supposed to tell me average angular velocity. Understand? Theta is given. Angular displacement is changing with time. The relation is exactly over here. You are supposed to tell me what? Omega. How can you find the omega? You'll say, sir, omega is very simple. So we say omega AVG is nothing but that is this total angular displacement or average rate of change of angular displacement upon time. That is omega T delta T up T delta theta upon delta T. So can I just say this will be nothing but final theta 2 minus theta 1 upon this T2 minus T1 exactly. You'll say, sir, how? See, delta S by delta T, what do you say? Final displacement S2 minus initial displacement S1. Same is the case over. Final angular displacement minus initial angular displacement, okay? Yeah, I'll tell you, when we will study this when we'll study this accelerations in the circular motion, don't worry about that. I'll tell you what is the direction of linear tangential acceleration or this centripetal acceleration, radial acceleration. Tangential acceleration will be exactly along this velocity only, but it depends. Understand? It depends. There is a condition. It can be along this one, parallel to that one, or anti-parallel to that one. Along that one or opposite to that one. We'll have to check both of those conditions. So we say in this case over here, first of all, find the theta 2. Sir, from this one, we can simply find this theta 2 will be nothing but put the value of 2 over here. What is the 3? That is 3. So 3 in this case will be 3 into 3, that is 9. 3 square 9. So 9 into 2, how much? That will be 18 exactly. 18 plus 3. So this will come out to be 21 exactly. Come on. Is this correct? I want you people to give me the answer of this one as soon as possible. Find what is the angular velocity. Next. Tell me what is theta 1 exactly in that case. So up to is equal to theta 1. So up to what? Up to what we are supposed to find, that is up to 3 seconds. Understand, from 0 to 3 seconds it is given. So can we say in that case this will be nothing but 2 into 0. So it will be 0 and this will be 3 only in that case. 100% I can say this will be 3 only. So can I just write over here theta 2 is how much? That is 21. This will be 21 minus 3 exactly. And what is the time in that case? You'll say, sir, that is nothing but 3 minus 0 exactly. You getting me what I'm trying to say? All of you? Come on. Find the value of the next one, that is omega at t is equal to 3 seconds. I'm waiting for your answers, okay? Rad per sec. And this is the instantaneous angular velocity. That is nothing but INS. That is nothing but d theta upon dt. Means we need to differentiate that one. That will be 4t only. Understand? 4 into 3, because that is 4t only. So that will be 12 rad per sec. Moving on to the next one. Yes. So what is this? Units and dimensions, okay? That's a very basic chapter, okay? I don't know yet. See, I cannot directly go from this to units and dimensions. Don't worry about that. I'll take the one shot of units and dimensions and I'll clear everything in that one shot. Don't worry about that. Chill scenes. So, what is this acceleration? One second. Acceleration is in circular motion, okay? First of all, what is this acceleration? You will say, sir, when velocity changes, acceleration comes. Change in velocity, rate of change of velocity with time, that is nothing but acceleration. Whenever there is change in velocity, we say acceleration. Body is basically, we say this is a car, understand? This car is basically increasing its speed. So this is accelerating, understand? This car is decreasing its speed. We say that's deaccelerating, whatever you say, understand? So this is nothing but acceleration that you say. In that case, acceleration, acceleration. Fine. So this velocity, this acceleration depends upon what velocity. When there is change in velocity, there is acceleration. Now the point over here is, change in velocity can either occur by two ways. You will say, sir, this change in velocity can occur change in velocity. This can happen with two ways exactly. The first one is, see, velocity is a vector. If we change the magnitude of the velocity, understand how much that is, 50 meter per second, 20 meter per second speed. Okay, we say speed, understand magnitude of velocity, speed. So if we change the magnitude, how much that is? So either we can change the magnitude, so velocity will change, acceleration will come. Because acceleration comes by changing the velocity. So we can change the velocity by changing the magnitude, by changing the magnitude, or by changing the direction. Understand? Because velocity is a vector. It depends upon the magnitude as well as direction. By changing the direction. By changing the direction. Understand? Either you change the magnitude of the velocity, velocity will change. Either you change the direction of the velocity, velocity will change. So whenever there is change in velocity, acceleration will come. Understand? So the velocity over here, when the particle is basically moving in a circle, in that case, direction of the velocity always changes. Because at this point, if you talk about this point, the velocity of the direction is tangential. Draw a tangent. So in this direction. At this point, the direction of the velocity is in this direction. Draw a tangent. At this point, the direction of the velocity is in downward direction. Draw a tangent. At this point, the velocity is something like this. At this point, the velocity is something like this. So it keeps on changing. It keeps on changing. So direction will always change whenever the particle is basically in a circular motion. So whenever the velocity is changing because of the direction only, at that point of time, the acceleration which will come is known as nothing but centripetal acceleration. Understand? So by this, centripetal acceleration will come. Centripetal acceleration will come, exactly. This is what we call the radial acceleration. Centripetal or radial acceleration, because it is along the radius. Understand? It is always towards the center. It is always towards the center. Understand? That acceleration which comes when the direction of the velocity changes. Understand? See, we say, sir, velocity acceleration is nothing but change in velocity. I am saying that in case of circular motion, velocity can change by two ways. Either by changing the magnitude, how much that is, or by changing the direction. You will say, sir, by changing the direction, velocity will change. So by changing the direction of the velocity, what type of acceleration will come? I'm saying that centripetal acceleration will come. The name of that acceleration is centripetal acceleration. Fine, we call this as centripetal acceleration. Now, on changing the magnitude of this one, on changing the magnitude of the velocity also, is it possible that the magnitude of velocity can remain constant in the circular motion? Yes, it can remain. So you say, for example, 30 meter per second. So over here 30 meter per second, over here 30 meter per second, over here 30. But direction of the velocity will always change, because at this point it is something like this, at this point it's something like this. So sir, I'll not change the direction, I'll keep the unique direction. Then you are going in a straight line. Understand? That is the point. So the acceleration which comes by changing the magnitude of the velocity is known as nothing but, tell me in the live chat, what is that? Tangential acceleration. Tangential acceleration. Fine. And it is along the tangent only. It can be in this direction or in this direction. I'll tell you afterwards. That was the Akash's question. Yeah, you got the feel of this one. Come on, just write crystal clear in the live chat. If you got this one. Okay. Fine. Yes. Whatever I teach, you will get to understand every bit of my lecture. That's the way I teach. That's how I teach exactly. Fine. Yes, we have a special class exactly at 7 o'clock. Now see, so we say this centripetal acceleration, I'll just write it over here. So we say this centripetal acceleration is nothing but, we say, sir, this centripetal acceleration is nothing but it is equal to the v square by r. Exactly. Fine. V square by r. You getting me what I'm trying to say? V square by r. So we can definitely write it as v is equal to r times of omega. So put it over here. So this AC will be nothing but that is r square, this omega square upon this r. This will cancel. So AC will be equal to r omega square. These are the two formulas for this centripetal acceleration. Keep these things in your mind. Understand? So it depends upon the v square upon this r. Understand? This is the formula for centripetal acceleration. What is centripetal acceleration? Which comes when there is a change in the direction of the velocity. So this is what we call the centripetal acceleration. This is what we call the centripetal acceleration. Okay. So now, is this centripetal always present in the circular motion? Yes. This is centripetal. I'll just write over here, always present. Always present in circular motion. Keep this thing in your mind, always present. What is the next thing that we need to talk about? The tangential acceleration. It is that acceleration which comes when there is a change in magnitude of the velocity. When there is change in the magnitude of this velocity. So velocity can be constant, magnitude of velocity can be constant, not velocity, okay? Speed can be constant, understand? Magnitude of velocity can be constant, or it can either change. It depends, understand? If I say, for example, over here, this is constant. So tangential acceleration will be, in that case, 0. If I say mod of v is constant, in that case, at will be nothing but 0, because this is nothing but change, rate of change of this velocity upon time, mod of this velocity, speed upon this time. So it can be 0 in that case. Understand? If this is constant. So the direction of this is, it can be. Now see, if dv by dt is coming out to be positive, like previously, if this rate of change of this is coming out to be positive, if this tangential acceleration is positive, we say at will be along vt, then this is the direction of at in that case. This is the direction of at. If dv by dt is positive, understand? If dv by dt is negative, this will be at. If dv by dt is negative, this will be the direction of at. Fine. We say this is deaccelerated centripetal motion, circular motion. This is accelerated circular motion. समझ आया क्या यार? चलो, let's move on to the next one. Now, what is this net acceleration? Whenever the body moves in a circle, if we say it has the tangential acceleration, magnitude of velocity is changing, it has the centripetal acceleration also. So, what is, I'll just write over here, it can be or cannot be in the circular motion. Understand? Depends. If magnitude of velocity is changing, in that case we say it will have. Now listen to me very carefully. If I say, for example, this is the tangential acceleration, your body is moving in a circle. This is the tangential acceleration, this is the centripetal acceleration. So can I say this will be the net acceleration, okay? Resultant of this one and this one, this will be the net acceleration. Can you tell me the value of this net acceleration? You will say, sir, A net will be nothing but that's root of, they are at 90 degrees with each other. So I can say that is nothing but AC square plus this AT square in that case. Sir, this A net we can definitely write is nothing but that is this V square by R, because AC is V square by R, it's square, plus this will be D of V mod of V upon this dt, exactly its square. We can definitely write it, or we can write it like this also, that is R omega square, because we write AC in terms of R omega also, R omega square also, that is R omega square. Just it will be this R omega square whole square plus dV by dt its square, exactly. Can we just write it like that? So this is basically the centripetal acceleration. Sorry, this is the net acceleration. Now comes the point of angular acceleration over here. Listen to me very carefully. If I just try to make the figure exactly, the particle is moving in a circle. Fine. If I say, for example, the particle is moving in a circle, it will have what? It will have angular velocity. This particle will be having the angular velocity. Particle has angular velocity. Understand? If the particle is moving in a circle, we say it has angular velocity. If there is a change in angular velocity, what is linear acceleration? You say, sir, linear acceleration is nothing but change in linear velocity upon time. Understand? Rate of change of linear velocity with time. With what rate velocity is changing with time? Now over here, if the particle is going in a circle, from this point of view, it will have angular displacement, angular velocity. If there is change in angular velocity, if angular velocity is basically changing, so in that case, in that case, can we say this is having the angular acceleration 100%? So can we just write this angular acceleration? This is nothing but, we say this is represented with alpha. So can we say this alpha will be nothing but that is rate of change of angular velocity, that is delta omega upon delta t, like linear displacement, like a linear acceleration, that is delta v by delta t. So we say this is nothing but average. Fine. If you want to find the instantaneous, that is nothing but, sir, that is this d omega upon this dt. Can we just write it like that? Any sort of confusion in this one? This is instantaneous. This is nothing but average. In general, what is the rate of change of angular velocity from this point to this point? Understand? That's nothing but average. So this is nothing but instantaneous. Fine. I hope you're getting me what I'm trying to say. Okay. The direction of this is also along this one. This is also the axial vector. This will be alpha. Over here, this will be omega theta in the same direction. Also axial vector. We say this is also the axial vector. Fine. Clear? Yes, clear, sir. Now, what is the relation between alpha and this AT? Could you please tell me what is the relation between alpha and AT? You'll say, sir, yes, we can tell you what is the relation between alpha and AT. Now see. Listen to me very carefully. If I say, we know V is equal to R times of omega. Differentiate this both sides. Differentiate both sides with respect to time. So what you will exactly get in that case, you will say, sir, that is nothing but in this case, this will be dV upon this dt is equal to, that is R. R is constant, take this R out. So this will be d omega upon this dt. Understand? You say, sir, what is this relation between alpha and AT? If this particle is in circle, understand, if this particle is moving in a circle, so if this is having the acceleration, if this is having the acceleration, if this is having the acceleration alpha, if this is having the tangential acceleration at, so in that case there will be the relation also, because the particle in circle is having both the acceleration, so relation will be there. So what do we say? This is what we call the A is equal to R times of d omega by dt, that is nothing but alpha. Now if you tell me, is this AC or AT? This is nothing but what? AC AT. Come on in the live chat. AC AT. Yes, AT, AT. Yes, this is AT. Akash, can you tell me why is this AT? Why is not this AT? AC? I need to know. Now see, why is this AT? See, Asha, tell me one thing. Is it possible that angular acceleration of a body is zero? Moving in circle. Is it possible that angular acceleration of a body is zero moving in circle? Huh? Is it possible? Nahin, this is not the reason. See why. See, listen to me very carefully. If I say, for example, mod of V is constant. Understand? Magnitude of velocity is constant. This particle is moving with a constant. This particle is moving. This particle is basically moving in this circle with a constant linear velocity. It is possible this can move in a constant linear velocity. Direction of the velocity can change. That will always change. So we say this is constant. So now from V is equal to R times of omega. If this is constant, velocity is constant, we say, sir, this is constant. Okay. Our radius of the body is constant. Understand that this is constant, this is constant, this is constant. Fine. So this will be constant. If this is constant, both are constant. This is a scalar form. This is constant, this is constant. Can I say omega is also constant? Omega is also constant, 100%. If magnitude of velocity is constant, omega is constant. Fine. If there is a particle which is moving in a circle, if mod of V is constant, so in that case, its omega will be also constant. This is the reason. Fine. If omega is constant, what is omega? If omega is constant, what is alpha? D omega by dt. With what rate? With what rate? Omega is changing with time. You don't know the reason. I'll tell you the reason. So with what rate angular velocity is changing with time? That is alpha. Angular velocity is constant. That is not changing. So can I say in that case alpha will be 0? 100%. So it is possible in a circular motion. Alpha can be 0. Angular acceleration can be 0. Okay. This is possible. So if alpha is 0 in this case, and already we said mod of V is constant. What is mod of V? What is acceleration? AT is what? You'll say, sir, that is nothing but d mod of V by dt. Rate of change of velocity, mod of V by this t. This is constant. So rate of this is not changing. So rate of change is what? That will be 0. So this is 0. So can I say AT will be 0? So in a circular motion, it is possible that if mod of V is constant, its angular acceleration is constant as well as its tangential acceleration can be also. Angular acceleration is 0. Its tangential acceleration can be also 0. So these two are having exactly relation with each other. Now you will say in this case, sir, is it possible in this case centripetal acceleration can be 0? Oh, no, that is not possible. We say centripetal acceleration AC is V square by R. Forget about that. That comes because of the direction. Forget about that. This is V square by R. Now, if mod of V is constant, it's constant. It's not 0. It will have some value. Means it is not changing. So that's why this is the rate of change of this. So this is 0. This is 0. But this cannot be 0. This is having some value, constant value. We'll put that constant value over here upon R. So this will have some value. So in case of if V is constant, this can be 0, this can be 0, this cannot be 0. That's why they are having their relation with each other. That's why these two are having their relation with each other. That's why this is 80. Now you got the feel. I need to know in the live chat. Drop a heart if you like this one. Now see, if I talk about this one, what is the linear velocity? You say, sir, linear velocity is s. What is the angular linear displacement? That is s. This is the analogy, okay? In linear motion, we study linear displacement. Over here, we studied linear displacement. This is the linear velocity in this case over here. Understand? When the particle is basically performing the circular motion, it has linear velocity, it has linear displacement, it has linear velocity, it has, we say, tangential acceleration, linear acceleration over here. Understand? Now, what about its angular terms? It will also perform the angular motion. Okay, when it performs the angular motion, this is theta. It will have angular displacement, angular velocity, angular acceleration. What is the relation? You will say, sir, S is equal to R theta. This is the relation. What is the relation between linear velocity and linear displacement? V is equal to R omega. Proved all the three. This is the relation between this and this. Fine. Now solve this question and drop the answer in the comments down below. Okay. Very simple question. Now, you might have studied previously in equations of motion. In linear motion, if acceleration of a body is constant, we say we can use these equations. We have studied this previously. That is, V is equal to U plus AT. S is equal to UT plus 1 by 2 AT square. V square minus U square is equal to 2AS exactly. If These are the relations we have studied previously when acceleration was constant. If I say over here, in angular motion, if alpha is constant, understand, because angular acceleration. So can I use this equation 100%? Can I use this equation 100%? Can I use this equation 100%? What is this? This is V is equal to U plus AT. Final velocity is equal to initial velocity plus acceleration, linear acceleration into time. Can I say this is final angular velocity is equal to initial angular velocity plus angular acceleration into time? Exactly the analogy of this one. But this is in what? Angular motion. Same, if angular acceleration is constant, we can use this. If linear acceleration is constant, we can use these equations. Same. This is linear displacement over here. This is angular displacement. This is linear displacement. Initial angular velocity, linear velocity. T time, alpha, angular acceleration. This is linear acceleration. Same exactly over here. So we can basically, these are the equations also called the equations of a rotational motion. These are also called the equations of rotational motion. Okay, keep this thing in your mind. Fine. So we say in this case over here, listen to me very carefully. We say in this case where theta is basically angular displacement and omega naught is initial angular velocity. Omega is final angular velocity. Alpha is angular acceleration. Same goes over here. You know, this is linear final velocity, linear final velocity, linear displacement. Fine. Thank you so much, ladies and gentlemen. How was the lecture? Come on, you like this? Basics of rotational motion is done. Basics of circular motion is also done. Okay. Even if you now, so we just have to add few more points in this one when we basically study in the rotational motion. V is equal to R omega will be studying in bit more detail. Understand? And some of the more extra terms like 2 or 3. Rest everything is same. First lecture of your rotational motion is done. Yes. So thank you so much, ladies and gentlemen. You can definitely follow me on Unacademy. This is my username over there. Hit the follow button as soon as possible. And apart from this YouTube platform, we have our own platform. Okay. Apart from this, Divyan Singh is saying something, okay? Basically, what you said in the initially, you shouldn't basically say that. And I was a model initially. Don't worry about that. Why am I? Why? You don't like me? You don't want me to teach? Okay, apart from this YouTube platform, we teach on Unacademy's own platform where country's top educators are basically teaching you. Okay. It's okay, fine. My heart is still with you. Chill scenes, bro. Apart from this YouTube platform, we have our own platform. That's nothing but Unacademy's platform where country's top educators are basically teaching you. Okay. So where country's top educators are basically teaching you, and you will be getting the live classes every single day over there. And you will be getting the weekly test every single day. And this is the structured courses that you will be getting over there exactly. And this is the unlimited access you will be getting over there as well. Okay. And apart from this one, if you take this Iconic subscription, you will be getting the personal guidance. And if you want this personal mentorship, you have to basically take this Iconic subscription. That's mandatory. Okay. So by taking this Unacademy's Iconic subscription, you will be getting the personal mentorship and you'll be getting the test analysis. Once you are done with everything, afterwards, you will have to basically, okay. Afterwards, you will have to basically analyze your test scores. Okay. Afterwards, you will have to basically analyze your test scores, in what portion you are lagging in what portion you need to work more, so that you will get the good score in the upcoming time. Okay. And experts guidelines are basically mandatory in that case for sure. Okay. So this is the study material that you're going to be getting in that case over there. So this is the study planners. These are the study planners. Next is you can take this plus subscription for 3 months, for 6 months, for 12 months as well. Understand? And you can take it for 18 months and you can take it for 24 months as well. Now, you can use my code in order to get the maximum possible discount for sure. Okay. Okay. We solve the mains problems on every single day. Okay. And by using this content only. And you see, you compare this content with the other channels also. You compare this content with the other channels also. What else you're gonna get from this one? And this was the basics of circular motion. Okay, basic kinematics of circular motion. What else am I supposed to say you in this basic lecture? Tell me. So you can take this Iconic subscription for 12 months, for 18 months, for 24 months as well. Okay, this is Yawar. You can take this, you can use my code in order to get the maximum possible discount for sure. Okay. And these are the batches which are running inside Unacademy right now. You can definitely enroll in this one as soon as possible. Okay. Next is, you should definitely basically use my code in order to get the maximum possible discount. This is my code. And these are the prices exactly. This is before price hike. This is after price hike. Before, after exactly. And for 12 months, this is basically the regular price. This is the discounted price. This is the regular price. This is the discounted price. This is the CBSE plus JEE combo offer. You can definitely go for this one. Use my code in order to get this maximum possible discount exactly over here. Next is, this is the biggest scholarship for test for IIT JEE aspirants. Okay. If you get the ranks accordingly, you will be getting the 100% scholarship on Unacademy. So use this code Yawar in order to get the maximum this while you basically enroll in this one. So go for this. So we have this beautiful feature on Unacademy, that's ask a doubt. You can ask this doubt every single time, and you can ask the unlimited number of doubts. You can ask the doubt any damn time. You'll get the high quality video solutions, that too in English as well as in Hindi language. Okay, you'll receive once basically how to ask a doubt. There is a doubts and solutions option over there. Take a picture and upload it on Unacademy, and make sure you basically crop this particular doubt. Okay, you crop this particular doubt. You crop this particular doubt exactly, and you need to basically, you'll get the solution within no time. Okay, thank you so much, ladies and gentlemen. It was really nice interacting with you. Subscribe to the channel, hit the bell notification, and like this and share this video so that you'll get the update every single time. Thank you so much. Bye bye, take care. Okay, thank you.